Good morning, everybody. Happy Monday. If you can give me some green checks in chat so I make sure you're with me, you can hear me, everything's going well. Hopefully everyone had a lovely weekend and ready to do some math. While you guys are doing that, again, if you had any questions from the learning guide that you wanted me to kind of clarify or go over, if you put in the section and then the number, that way I'll know exactly which questions to do. I just wanted to mention a few things about where we are while you guys are maybe looking at your learning guides. So we spent some time last week working on unit number 1, and we've done the first 3 lessons there. So here's unit 1. You have the learning guide, you have your first lesson, second lesson, third lesson. And then there was a quiz. The first quiz came after the third lesson. I was hoping you guys could finish that over the weekend. So if you haven't attempted that, it should be done today. The last lesson is actually kind of 2 lessons in one, but it's not terribly difficult, and I think you guys will have no issues with it. So I put them together, 4 and 5. That's today, the October 19th. And then there's a little quiz, and then you guys can submit your learning guide. So really after today's lesson, that's it for unit 1. So what I was kind of thinking is you guys could watch today's lesson, do the work maybe sometime today or tomorrow, and then submit your learning guide tomorrow. And then after you've submitted your learning guide, I can give you the password for the test. The test is for unit 1 is the same length as unit 2, but we didn't cover as much material, so there's not as much on it. So generally it's a little bit more straightforward of a test and kind of less tricky questions and things like that. So I'm kind of hoping you can get that done by Friday. Perhaps that's a bit optimistic, I'm not sure. So that gives you the whole week to find some time to do it. Again, I think there are 20 questions, no real surprises in there. So hopefully that works for you guys in your schedules. And yeah, so I see Taylor has put in a couple questions from the learning guide. Question 4 on page 6, that'll work, I can find that. Thank you, Alex. Anything else? 1, 9, 10, simplifying radicals. Just gonna clear out these check marks. Looks like Damon and, just Damon. Simplifying radicals number 8. All right, I'm just gonna jump right into these questions. So simplifying radicals 1, 9, 10, simplifying radicals 8, so 1, 9, 8, and 10, and then question 4 on page 6. So let's see how I can do here. All right, let's start with simplifying radicals number 1, 9, and 10. This looks like the first one, I think, Taylor. Compare and contrast the difference between simplifying a fraction and simplifying a radical. What is the ultimate goal for each? Okay, so just a basic kind of understanding type question. Compare and contrast. So simplifying a fraction, what are we trying to do when we simplify a fraction? Let's say I had like 2 over 6. What's the ultimate goal here? Well, I guess what I'm trying to do is figure out the largest number that goes into both those, if there is any. Sometimes there won't be, and that's okay. So are there any numbers that go into both 2 and 6? Yes. I can get a 2 out of both of those. So this is equivalent to 1 over 3. So I've simplified that fraction. Now, if I had a radical like, I don't know, let's go with square root of 12. Is there anything simpler that I can pull out of there? Well, I know 12 is 4 and 3, so I'm going to break that up into 4 times 3. And then I take the square root of each of these things, and I get 2 times root 3. So I guess the main idea here is what Abby just mentioned. It's just getting everything into lowest terms. You just want everything as simple as possible. And when we do today's lesson, you'll see why that's kind of important. And same thing goes for when dealing with fractions. You don't want to be multiplying or dividing fractions and get these really big numbers. So if we can simplify them first, it can reduce the numbers and make things a little bit easier in terms of work. So it's kind of like a work thing. It's just sometimes easier to reduce these things before we before we do any mathematical operations. Simplest form. If you want to think of having radicals in simplest form as that, then that's completely fine. That works. So that's kind of that one. Number 9, and Ava had 8 as well. So maybe we'll go 8, 9. Simplify each of the following. Leave in simplest radical form. I told you guys to leave 8, Ava. So don't worry about 8 because some of the things we're going to do with having these radicals under, powers under a square root sign, we're going to deal with simplifying those things later. So I guess you could have pulled out the largest numbers. Maybe I'll do B here real quick, and we'll just leave the A's and B's together. So if I had the square root of 18, what can I break 18 into? I can break that into 9 times 2. I get A3, B5. And then I take the square root of 9, which is 3. So I have 3 times 2A cubed, B to the 5th. So if you got it that far, that would be great, because you were dealing with the 18 out front. I'm not sure if they simplified the A's and the B's yet in the answer key, but you should not worry about that right now, because that will be something we actually cover in the next unit, unit 3. So if you could deal with the 52, the 18, and the 24 out front, and then not worry about the A's and the B's, that would work. But if you just left it because I said, hey, don't worry about it, then that's fine as well. So it looks like 9 and 10, and then Alex, I'll get to your question in a second. So a square has an area of 240. What is the length of each side? Leave in simplest radical form. All right, so we have a square, and we know that we have 240 centimeters squared is the area. So we have some length. Maybe we'll start this. Area of a square is length squared. And I know in this case I have length, and they're the same thing because it's a square. So it tells me the area is 240, so I'm going to plug that in for the area. So 240 is L squared. And then I need to figure out what L is, so I'm going to take the square root of both sides. And I'm going to end up with the square root of 240 is equal to L, because the square root of a squared is just L. So basically all this question is asking is, can you put the square root of 240 into simplest radical form? So I need to figure out the largest perfect square that'll go into 240. And if I don't get it right away, I can just do it more than once. So what are some perfect squares that go into 240? If you have your chart out with all your perfect squares on it, you can just look at that. So I have mine right here, just in case you've forgotten what they are. They're there. That was lesson 2. So I have perfect squares like 25, 36, 49, 64, 81, 100, 121, 144. 4 times 4 times 15. So 16 times 15 is 240, is that right? Perfect, 16 times 15. I like 16 because I know that 16 is just 4 squared. So what I'm going to do is I'm going to break it down. 16 times 15 is L. And then I'm going to break it into 2 pieces. Square root of 16 is just going to give me 4. Root 15 is equal to L. And then 15, I need to think, are there any perfect squares that go into 15? 1 doesn't, or 1 goes in there, but we don't use it. 4 doesn't. 9, no. 16, no. 25, no. So I think we've found that the largest one was 16. So there we go. We have that one done. And this next question is the exact same question as the previous one, except instead of dealing with a square, we're dealing with a cube. So we have our cube. The volume of our cube is going to be 2160. And instead of length squared, because it's a cube, the volume of our cube is going to be length cubed. Same process, we're going to substitute this 2160 in for L cubed. Instead of taking the square root of both sides, we're going to take the cube root of both sides. I'll just start up here to give myself some room. 2160 is going to be L. So I need to figure out the largest perfect cube that goes into 2160. I don't know that off the top of my head, so I'm just going to plug a bunch into my calculator. So I take 2160, and then I just pick one, like 64. Does that go in? Nope, 33.75, so that doesn't work. So 2160 divided by maybe 216, that's going to go 10 times. So I have 216 times 10, cube root of that. Maybe some of you are saying like, well, how did you get the 216, Mr. Borden? All I've done is I've just picked the perfect cubes that I have. So I've just looked at my list, 1, 8, 27, 64, 125, 216, and then I just keep dividing the number I have by those until I get a whole number that comes out. I don't want to deal with any decimals. I want perfect integers. So that's kind of what I've done. So I know the cube root of 216 is 6. So I get 6 times the cube root of 10 is equal to the length. So that was just basically getting you to put the length or the volume into simplest radical form after you've taken the cube root of it. Can you use the list for your test? Technically, no. But what I always encourage students to do is as soon as you sit down to write this test and the one in the next unit, what you should just do is grab a piece of paper that's blank, because you can't really bring stuff into your test, and just grab your calculator and just write down as many as you can remember. Just 1 squared, 1, 2 squared is 4, 3 squared is 9. Go as high as you can by memory. And then if you can't remember like 12 or 13, then do 12 squared, 144 on your calculator, 13 squared. And then write those down, and then do the same thing with your perfect cubes up to maybe like 6. And then just leave those at the top of your, your scrap paper. And then those will be there. So technically you can't bring them in, but you can always just sit down at the beginning and just write them all down, because it'll make your life a lot easier. So that is my suggestion to you. So that was number 10. Alex had a question on page 6. I'm just going to jump back to make sure I get that one. Number 4 on page 6 of the learning guide. All right, there's page 6, number 4. Anything in particular there, Alex? Maybe I'll pick one and then I'll leave one. Maybe I'll do F here. And I'll do F maybe over on the side. Did anybody have any questions on any of these in particular? So I have square root of 28. I need to figure out the largest perfect square that goes into 28. And I'm thinking 4 goes into 28, so I go 28 divided by 4. That gives me 7. And I'm thinking 7 isn't a perfect square, so I'm going to break this down into 4 times 7. And then I'm going to say, I'm just going to bring the 6 along for the ride. Take the square root of 4 is 2, so I'm going to get 6 times 2 times the square root of 7, where that 3 came from. And 6 times 2 is 12 times the square root of 7. So that's just one of those, 12 root 7. That's simplified now because there's no perfect squares that can go into 7. Yeah, there always are tricky ones, Abby. So when you say something like it couldn't be simplified any further, yeah, that's kind of just when you're doing problems with these sort of things, you're going to end up with some that just can't be simplified. And that's just, it's once you're able to recognize those, there's no perfect squares that go in there, then just you're good to go. Don't be afraid of your answer. Like be confident in what you're doing. If you get to the question, you're like, well, this can't be simplified. Don't think that it's something you're doing wrong. It happens. So it's a good point. Taylor, why 6 times 2? That's a good question. So when I take the square root of 4 right here, Taylor, because I've found the largest perfect square, which is square root of 4, if I just had a question, I said, Taylor, what's the square root of 4? And you said, oh, Mr. Borden, that's easy, that's 2. And then all we've done is just done that mathematical operation. So we've taken the square root of 4, and then we get 2. And then just to simplify it, I can do the multiplication, and I get the 12 from the 6 times 2. And then I'm left with the root 7 because I can't simplify that any further. Alex, I assume you weren't saying K like OK, but you were saying K like letter K. I am going to just get rid of this stuff. So a little bit of room here to do K. All right. So I have -5 times the square root of 56. And I'm thinking largest perfect squares that go into there. So 56, maybe like 16 and 56, does that work? So 56 divided by 16, no, that doesn't work. 56 divided by 4, does that work? Yes, 4 and 14. So go with that. -5, 4 times 14. And then I'm thinking, is there any perfect squares that go into 14? Did I pick the biggest one? None of them go in there. So like 4 doesn't go into 14, 9 doesn't go into 14. So I'm thinking that is the largest. So again, I'm going to break it into 2 roots, root 4 and 14. Square root of 4 is going to give me 2. So -5 times 2 times root 14. And then -5 and 2 gives me -10 times the square root of 14. Can't simplify the 14 any further. There's no perfect squares that goes into that. And then, yeah, I'm happy with that. The 5 and the 2 out front gives me the -10. So that's kind of as far as you can take it. Taylor wanted N as well, LMN. Maybe I'll do this guy down here. So 108, largest perfect square that goes into 108. Break out my calculator, I go 108. I could try 16. Nope, that's 6.75. 108, 36, 36 and 3. Perfect. So 36 times 3 gives me 108. Once you guys get the hang of it and you get a little bit better at these things, just skipping the one step in here where I write the 2 radicals separately, you can do that. I don't mind that. The 2 and the 6 gives me 12 and the root 3. So that was N. And I think that was all the questions. Maybe I should just look at G because you did mention that G wasn't simplified any further. Yeah, something like 30. There's only so many numbers that go into 30. You get 5, 15, 2. None of these things are perfect squares. So if it's root 30 and there's nothing that goes in there, then, you just move on. That's it. It's simplified already. It can't be done any further. That'd be kind of like if I had a fraction, 17 over 24. Are there any numbers that go into both 17 and 24? No, there aren't. There's nothing that goes into both of those things. So, it's a fraction, it's already simplified. And it won't happen a lot, but it might happen every once in a while, so just be aware. There you go. So those are a few questions. If you have anything else that comes up, you're like, oh, shucks, I forgot to ask about this, then that's fine. But if you don't mind me going on to the lesson for today, I'm going to do that. And then you guys will have some time to work, I think. All right, so the lesson here is adding, subtracting, multiplying, dividing numbers with radicals. And the reason I put these two lessons together, the adding, subtracting, the multiplying, dividing, is because you guys have already done stuff like this before with adding and subtracting polynomials. So like the first example we're gonna look at here. So if you get confused or you're not really sure how to do them, just kind of think back to just simple X and Y questions. And it's the exact same process for adding and subtracting. You can only add and subtract like terms. So you can only add or subtract like radicals. So let's take a look. The first one's a question that you've done maybe lots of times in grade 9. And then we're going to look at a similar one from grade 10. So the first example here, we have 2x plus 3y plus 6x minus y. So this isn't actually a radical question. This is something you would have done in the past. But it serves a pretty good example. So what we want to do is identify any like terms. And when we did the review questions, some of you guys have done these questions different ways. So I say, okay, I have 2 x's and I have 6 x's, so I'm dealing with x's. And then I have y's as well. I have 3 there and I have negative 1 there. So what I want to do is combine my like terms. How many x's do I have? Well, I have 2 and 6. Gives me 8 x's. And then I have 3 minus 1 is going to give me 2y, sorry. And that's it. That's simplified. I have 8 x's, I have 2 y's, and I'm done. One thing to kind of, I guess one thing to mention, or it's really important, when you're adding and subtracting polynomials like these, you notice that I didn't do anything with the x's and y's. I just dealt with the numbers out front. So if I had the 2 and the 6 and I added them together, I had 8 x's. I don't have 8x squareds. I don't do anything fancy with the x's. They're just, I have 2 apples, and then I have another 6 apples. If I add them together, how many apples do I have? I have 8 apples. So the x's are apples sort of thing. And the same rules apply for radicals. So let's look at the second one, letter B here. Think about the root 3's as kind of like apples. I have 2 there, I have another 6 there. And then maybe I have some bananas here. I have 3 bananas and I'm going to take a banana away. So how many apples do I have? I have 2 plus 6. So I have 8 times the square root of 3, or 8 root 3's, or 8 apples. And then I have 3 minus 1 is going to give me 2 bananas, or 2 root 5's. So literally, the question over here and this question over here are both the exact same question, except all I did was I replaced the x with a root 3 and the y with a root 5. So we ended up with the same answer, but it's the same process, and that's why I included both those. So that one's kind of a simple one to get started. Let's look at a little bit more challenging ones. Rarely will we ever be given anything that's just, really basic like that. Now that you guys have spent lesson 3 working on simplifying your radicals, realizing if there's any perfect squares in there that you need to pull them out, this is what the next question kind of involves. So if I look at it, I see, first thing, little light bulb should go off in your head here. Square root of 25. Oh my goodness, that's a perfect square. I can actually do the math there. I can actually simplify that guy. So I know the square root of 5 is, or 25 is 5. And then I have 2 root 17 and minus 3 root 17. Are there any perfect squares that go into 17? 4 doesn't go in, 9 doesn't go in, 5 doesn't go in, or 25 is too big, so no. So what I'm going to do is maybe I'll do this in 2 steps just because it's the first time. So I have positive 2 minus 3. So I'm just going to bring my 5 down, and then I'm going to combine like terms. I have 2 root 17's, and I'm going to take away 3. So I'm going to end up with negative root 17. And that's it. I can't simplify that any further. So the important thing here is that you recognize that the root 25 was a perfect square. and you actually simplified that because, as you're going to see here, sometimes it's important. So let's look at D. Another example of the same sort of thing. Again, you'll start to recognize these things really quickly. 18. So again, a light should go off in your head. You should say, oh, there's a perfect square that goes into 18, and that is 9. So I'm going to get 2 times 9. 9 and 2 gives me 18. And then I'll just bring down this negative root 2. And I'm going to do this, well, maybe I'll do it in 2 steps. So the root 9 is going to give me 3. And then I'm going to have 2 times 3. I'm going to do the multiplication here. Should give me 6 times square root of 2 minus root 2. So I'll just finish this off beside 6 root 2 minus root 2. So now this question is just kind of like letter B that I did up above. I'm combining like terms. And I don't write in a 1 in front of this guy, but we just assume the 1 to be there. So I'll just maybe put it in red. So I have 6, and I'm going to take away 1. So how many root 2's do I have? I should have 5 root 2's. So there's kind of a lot of stuff going on in that example, but it's all stuff we've done before. The first part, if you just look at the 2 root 18, you probably could simplify that. And then once you've done that, you're just going to combine your like terms. In this case, they're radicals together. So you had the 6 and then the minus 1. So I'm thinking this is all stuff you've done. Why did I multiply by 3? Because the same deal, Taylor, the square root of 9 here is going to give me 3. So I just skipped a step. I guess I could write it down here in black. So I have 2 times square root of 9 times the square root of 3. And then I'm going to subtract root 2. And then I took the square root of 9, which gave me 3. And then I did the multiplication. So this was a step I skipped writing the 9 and the 3 together as 2 separate radicals. All right. So the first couple were square roots. Now these ones next two are cube roots. So exact same process. You need to look at it and you say, do I have any like terms? 128 and 54. Those are definitely not the same thing, so I just can't combine them together. One kind of mistake students will make, I almost don't even want to write it down. I'll just write it quickly and erase it, is sometimes students will go, okay, I have 2 and then there's a 1 here, so I'm going to go 2 minus 1. And then I'm going to have the 128, and then I'm going to subtract 54. Please don't do that. That's not how we add and subtract radicals. We just combine like terms, just like we dealt with polynomials. So don't think that because you're just subtracting them, you can subtract what's under the radical sign. I say that because once we get to multiplying and dividing, that's kind of what we're going to do. So I'll explain that here in a second. But let's do this question first. Okay, I can't combine like terms because I don't at this point have any like terms, but I have 128 under my cube root sign and I have 54. So I need to think, are there any perfect cubes that go into these things? And 128 has a perfect cube that goes into it. So that's going to be 64 times 2. So what I'm going to do is I'm going to break it down. The 2 is just going to come along for the ride out front. So I have the cube root of 64 times 2. It's going to give me 128. What about the 54? Are there any perfect cubes that go into 54? So if you have your sheet out, you can just look at it. If you just want to write all the perfect cubes down, you'd have these. 54 is going to be, is anybody writing? 27 is 3 cubed times 2. All right, so I'm going to take the cube root of 64, which is going to be 4. And I'm going to take the cubed root of 27, which is going to give me 3. So I'm going to have my 2 times 4 times the cube root of 2. Then I'm going to subtract. The cube root of 27 is going to give me 3 times the cube root of 2. And then I have some multiplication out front here. So I'm going to multiply the 2 and the 4 together. Give me 8 times the cube root of 2 minus 3 times the cube root of 2. Now, probably you guys can see where we're going with this. Now we have 2 like terms. We have the cube root of 2. I have 8 of them, and then I have 3 of them. So I'm going to have to do some subtraction. Most of these questions will kind of work out this way, where you end up having to simplify your perfect squares or perfect cubes, pull them out, and then you'll have some like terms underneath, and then you can add or subtract them. So that's just kind of what this one worked out to be. 8 minus 3 is going to give me 5, and then I'm going to have the cube root of 2. So that is where I will end with that one. We'll do one more here and then see how you guys are feeling about these sorts of things. I have the cube root of 125 and then the square root of 45. So I know the cube root of 125 because 5 times 5 is 25 times another 5 is 125. So that's actually a perfect cube. So I can just simplify that to 5. And then 45. Are there any perfect squares? Notice that this one has the cube root, and this one, I don't have anything, so I know it's just the square root. So if there's nothing there, we know it's a 2. Perfect squares that go into 45. I'm going to break it down into 9 and 5. And then I'm going to take the square root of 9. It's going to give me 3 times root 5. Because all I've done here is taking the square root of 9, and then I just drop the root 5 down, because I can't simplify that any further. Now that I'm here, 5 minus 3 root 5, I have a 5 out front and a root 5, but those aren't the same thing. The square root of 5 is not the same thing as 5. If I were to actually plug the square root of 5 into my calculator, I'd get a decimal answer that would go on forever, so it's not a perfect square, so I can't do anything with it. And then the 5 and the 3, I can't simplify because I have 5 just whole numbers, and then I have 3 times root 5, and these are completely different things. This would be like having 5 trees, and this is like 3 apples. I can't combine my trees and my apples together because they're definitely different. So I'm done. Once I get there, I am finished. There's nothing I can do to further simplify that. That's as good as it gets. So that's kind of adding and subtracting in a nutshell. Same sort of process that we've been doing. First, you gotta simplify anything, kind of like when we dealt with fractions. When you deal with fractions, you wanna simplify first and then do any sort of calculations you can. How are you guys feeling with that? I've been talking a lot here. If you want to maybe put in like a smiley face or confused face or a thumbs up, or just let me know how you're feeling about it. If it's kind of whoosh right over your head, let me know. I can maybe do a few more examples, or if you guys are ready to kind of move on to the next stuff. A little confusing. I got a thumbs up, another thumbs up, pretty good. I guess the key here is just to remember to break the questions down. If you kind of are starting to get the hang of finding your perfect squares and cubes like we did from the last lesson, then, just focus on one part of the question at a time. And then once that's kind of out of the way, then we can combine the terms together. So this is all stuff you've done before, but it's never probably just been put all together. Damon, I like that. The thumbs up and down. It's, you're coasting. And I know from doing this or teaching this course that students at first, it takes a little bit of work to pull those perfect squares out. And then once you kind of get the hang of it, and once you've seen these perfect squares get simplified again and again and again, you kind of start to see the patterns and you kind of get to understand. So it's just kind of one of those things that comes with practice. You get a little bit more confidence with them and it should get easier. Haley is looking cool as a cucumber, and I appreciate that, Haley. We can probably just move on to the multiplying and dividing, and we'll see how that works out for us. So again, we're going to look at just a simple polynomial example first, and then we'll do a couple of the radical ones here. So the first one is 2x times 4x. If I said in grade 9, hey guys, multiply 2x by 4x, what would you get? Now, I'm not going to show this in a bunch of steps because you guys could probably just figure it out right away, but you're going to multiply the 2 and the 4, and you're going to get the 8. And then x times x is going to give us x squared. So the difference between adding and subtracting and the multiplying is when we add and subtract radicals, whatever's under the radical sign just stays the same. So if I had 2 root x and 5 root x and I was adding them together, how many root x's do I have? I have 7. So the root x just stays the same. But in this case, when we're multiplying 2x times 4x, we multiply the 2 and the 4, and we need to multiply the x's, so we get the 8 and then the x squared. So the difference here is that we're actually doing the multiplication with the x's, where when we're adding and subtracting, we're just combining the like terms. So let's look at a radical one. It's the exact same example, except we have a radical in there. So the 2 and the 4 again, I'm going to multiply the 2 times the 4, and I'm going to get the 8. And I also need to multiply my radicals together. The 2 times the 2 is going to give me the square root of 4. Now, you're probably thinking, that's a perfect square, Mr. Borden, and you'd be right. So I have 8 times the square root of 4 is just simply 2. And 8 and 2 should give me 16. So, a little bit different, but stuff you've done before. When you've multiplied these things before, you do the same sort of process. So, let's look at a few more examples that maybe are a little bit more difficult as we go here. The next one is the square root of 3 times the square root of 3. Now, probably some of you have figured out what this is going to work out to be already, but let's do it. When we multiply radicals, we multiply the number that's under the radical sign. So I'm going to go the 3 times the 3. Now I could write it as square root of 3 times 3, and then I could write it as square root of 9, and then I know the square root of 9 is just simply 3. So when I multiply squares together, or square roots that are the same, I end up with whatever was just underneath the radical sign, which is kind of an interesting thing that happens. Maybe have a go at D and see if you kind of get the idea here. I'm going to maybe warn you that there's 2 ways to do D, and no way is any more correct than the other. So I'm going to just draw a little squiggly line here, and I'm going to do it 2 different ways, depending on how you end up doing it. So some of you probably will try it and get one answer, and some of you will try it a different way and get the same answer, but let's just see if you can just have a go at it. So multiply the numbers out front, multiply the numbers under the radical sign. I'll give you a second for that. All right. how many of you went 3 times 4 gives me 12, and then root 12 times root 2 gives me root 24. How many of you did that? You want to give me a green check mark if you did it that way. I'm not saying you needed to necessarily finish the question there, but if you just you ended up doing that. Yes. Taylor, Jade, Alex, perfect. So there's nothing wrong with doing it that way. One thing that I will point out, look at that, 6. Yeah, perfect. I figured, and that's fine. And this is going to happen a lot in questions when you're doing these sorts of things, and you just multiply them and you've done everything right. There's nothing wrong with that. The one thing that you need to kind of realize once you get to the end, you need to ask, is there anything in there that I can simplify? Is there anything I can pull out? Any perfect squares I'm dealing with? So if I look at it, I say, 24. I know 24, and put a little star here, must simplify. 24. So 24, the square root of 24 is a decimal, but there is a perfect square that goes into 24. So I'm going to write this as 12 times 4 times 6. And then I get 12 square root of 4. It's going to give me 2 root 6. And 12 times 2 is 24 root 6. So root 6, no perfect squares that go into that. So you can leave it as that. That is a good final answer. Some of you will be doing it the other way. And again, the second way I'm going to do this same question, it's no more correct than the first way. It doesn't matter how you do it. I will recommend the second way because it generally works out to be smaller numbers that are easier to deal with in terms of multiplication, but it's not any more correct. So if you did it the first way, that's good. If you did it the second way, I'm going to just rewrite the question down again here. 3 root 12 times 4 root 2. The first thing I notice is the root 12. And I think to myself, root 12. There's a perfect square that goes into root 12. And what I can do is I can simplify this right off the go. So I have 3 times 4. 4 and 3. 4 and 3 give me 12. And 4 is a perfect square. So I have that one, and then I'm just going to bring the 4 times root 2 along. All right, so I'm going to simplify. I haven't even multiplied yet. Even though the question's telling me to multiply, I haven't even done that yet, which is fine. And then I have my 4 root 2. So I have 6 root 3 times 4 root 2. At this point I can multiply, and I get 6 and 4 is 24, and 3 and 2 is 6. And I end up at the exact same answer, but I just simplified first. So this is kind of like when you're multiplying fractions. What you can do is simplify your fractions before you multiply, or you can multiply and then simplify after. I prefer to do the simplification first, the second way I did it, because I just find that if I simplify first, the numbers, generally speaking, are a little bit smaller to deal with. It's easier to recognize the perfect squares because I've only memorized my perfect squares up to 12. So it's just kind of the way I choose to do it. So I try to simplify first, and then if that's possible, then I just continue. It's sometimes you're going to multiply 2 numbers together that can't be simplified, and then you're going to get one after the multiplication that can be simplified later on down the road. So it's not necessarily a way that works all the time. Let's look at the last couple examples because these ones are a little bit more work, but nothing impossible. Letter E. This is the distributive property of multiplication. You guys probably learned it as feeding the chickens. Did anybody heard of feeding the chickens This is how I always taught it, because I like to feed the chickens. So you can imagine we have a little fence here. If you haven't heard this story before, maybe this is your first time learning about feeding chickens. Here's my little fence. Think of my brackets as my fence, and I have some food out here in front. You've never heard of feeding the chickens? Oh my goodness. I have my food out front, and when I multiply a number by... No, but I know what distributing is. Oh my goodness. You guys, you need to have a math teacher with a little bit of creativity, I think. This is how I learned it when I was a kid. Maybe that's why it's stuck. Every once in a while, I guess a teacher teaches it this way. Only in real life. Well, I'm sure you have some delicious eggs at home. Feeding the chickens. You gotta feed both your chickens. So there's 2 radicals in here. I need to multiply the 5 by the first one, and I need to multiply the 5 by the second one. It's called the distributive property, feeding the chickens. Sometimes, I guess when you learn this in grade 7 or 8, when a student misses one of the multiplications, and I tell them that they killed a chicken, they get really sad, so it doesn't happen anymore. It's just kind of a lighthearted way to think about math. And I'm thankful that Bria is supporting me here with this feeding the chickens thing. I'm not just a crazy person talking about feeding chickens in math. So let's do the multiplication. If you don't mind, I'm going to do it in one step. Not one step to the answer, but just the multiplication in one step. I'm not going to write the root 5 times both of these things. So I'm going to go root 5 times 2 root 3 is going to give me 2 root 15. Because I'm going to multiply the root 5 by only the root 3. I'm going to leave the 2 alone. I don't want to deal with that 2, because I don't have anything in front of my root 5 to multiply by the 2. And then I'm going to multiply the root 5 by the root 7. So I'm going to have, these are all positive, so positive. The 5 is just going to come along for the ride out front, and then 5 and 7 together give me the square root of 35. So I've just distributed the root 5 through the brackets. Fed my chickens. You guys will never forget that, hopefully. So now I need to say, is there anything I can do to simplify these things? Perfect squares that go into 15, are there any? Are there any perfect squares that go into 35? And I'm thinking there aren't any. So I can't add root 35s and root 15s together because they're 2 different things. There's nothing else to do in the question, so I'm just done there. That's it. Finished. There's no simplification necessary once you get there, because the 35 and the 15 don't have any perfect squares that go in there. So I can move on to the next question. Now, forgive me for clearing some room here, but I'm just going to have to get rid of these. All right. Now, I'm pretty sure you guys have learned this as FOIL. If you haven't learned it as FOIL, then I'm not sure how else you would have learned it. So FOIL stands for first, outside, inside, last. It's a little acronym to remember how to multiply terms with 2 terms in each of the brackets. So if we have this sort of scenario. So what I'm going to have to do is, and this is going to, I've left some room below this one because it's a bit of a long one. What I'm going to do is this. I'm going to multiply my 3 root 10 by my 4 root 7, because that is the F of my FOIL. Are you guys talking about FOIL, or are you guys still talking about the chickens? I think you guys are still talking about the chickens. So first, the 3 times the 4 is going to give me, I'm going to leave some space here. 3 and 4 gives me 12, and then the root 10 and the root 7 gives me root 70. So there's the F of my FOIL. So I have first, and then I have my O gives me outside. So I'm going to do my outside terms. And again, there's nothing in front of the radical sign here, but I can just assume there's a -1. You're talking about FOIL? My goodness. What have you guys learned? You're going to have a talk with your grade, 7 and 8 math teachers. So 3 times the -1 is going to give me -3. I want that. So 3 times negative 1 gives me negative 3. The root 10 times the root 5, root 50. So there's the f and the o. There's the first and the outside. And then I'm going to do my inside two terms. So I'm going to multiply the second term by both in the second bracket. The 4 and the 4 together give me the positive 16. And then I'm going to have my 6 and my 7 multiplied together are going to give me the 42. So there's the inside, and then the L is going to be the last two terms. So 4 times the negative 1 is going to give me negative 4. The 6 and the 5 is going to give me root 30. So hopefully you guys remembered how to multiply those types of things, and normally you would have seen them with maybe like x's and y's, but now we have radical signs in there. So at this point I need to figure out if I have any perfect squares I can simplify. So 70, are there any perfect squares that go into 70? Just 4 go into 70. I split that up into 4. No. Can I do anything with the 70? 25 doesn't go into 70. 36 doesn't go into 70. So I'm thinking that the 12 times the square root of 70 is as simple as it's going to get. How about 50? Is there anything I can simplify the 50 down to? 50 I know is going to be 25 times 2. So I'm going to simplify that here in this next step. 42. It's the largest perfect square that goes into 42. 42. If I divide it by 4, get 10 and a half. 42 divided by 9, that doesn't work. 42 divided by 36, that doesn't work. So it doesn't look like there's any perfect squares that go into 42. So I just leave it as square root of 42. And then 30. Are there any terms that go into 30 that are perfect squares? So 4 doesn't go into 30, 9 doesn't go into 30, 16 doesn't go into 30, 25 doesn't go into 30. So I have 4 root 30. So I'm just going to simplify this 1 that ended up being 50, and then I'm done. So I'm going to just carry everything down. 12 times the square root of 70. In this case, I don't have to worry about the 3 out front quite yet. The square root of 25 is going to give me 5, and then the 5 times the 3 are going to give me 15. When I get here, I need to say, are there any like terms? I have root 70, I have root 2, I have root 42, and I have root 30, and none of those are the same. So I can't combine any like terms. It's a big mess of an answer, but that's it. That's as far as I can go. I've done the multiplication, I've simplified my radicals, and I've tried to combine any like terms. So that's it. That's my answer. And sometimes it's going to work out that way where it's not really wonderful and everything works out and you just kind of end up with a mess of an answer. I have one last one to do, and I'm going to apologize to you guys because I know I didn't leave you enough room, so you might want to just flip your page and put it on the back, but I thought if I had it on the back side of the page, you would just miss it altogether. So I put it on the front side, but I suggest you rewrite it on the back because it's going to take some work here to get this little fella done. If I had something like, I don't know, x squared, I would write it as x times x. Anytime I have something squared, I'm multiplying it by itself. In this case, it is absolutely no different. I'm squaring everything inside the brackets. So what I'm going to do is I'm just going to rewrite the question as 2 times root 5 plus root 6 times 2 times root 5 plus root 6. I'm just going to write it out twice, because that's what squared means, multiplying it by itself. Everything in the brackets gets multiplied by itself. At this point, I'm going to remember the FOIL, which Abby has never heard of before, but she's really good at distributing, so she doesn't even need to think about it that way. And I'm going to see what happens. So I learned it as first, outside, inside, last. So I'm going to multiply my first terms together. I'm going to multiply my outside terms together. I'm going to multiply my inside terms together, and I'm going to multiply my last terms together. FOIL. First, outside, inside, last. So let's go ahead and do some of that multiplication. The first one here, 2 root 5 times 2 root 5 is going to give me 4, and the root 5s together are going to give me root 25. So that's my first. My outside is going to be a 2 times a 1, which is going to give me 2, and then root 5 from here, and the root 6 from here together gives me root 30. And then I'm going to do my inside, so root 6 times 2 root 5 is going to give me 2 times the square root of 30. And then my last is going to give me root 6 times root 6, or plus root 36. So one step out of the way, I've done my multiplication. Now I need to think, I can do two things. I can either simplify and then combine like terms, or I can combine like terms and simplify. Or if you're really, really on the ball, which I don't recommend because it's easy to make mistakes, you can simplify and combine them like terms at the same time. But probably not the way we want to go about this. So I'm going to simplify first, and then I'm going to combine my like terms. First thing I notice here is my perfect squares that I've run into. Because I multiplied root 5 by root 5, I got root 25. And then because I have the root 6 times the root 6, I get root 36. So those are both perfect squares. So I'm going to just simplify my perfect squares first. Root 25 is actually 5. I have 2 times the square root of 30 plus another 2 square root 30s. And then root 36 is just going to give me 6. According to order of operations, I need to do my multiplication before I can do my addition. So I'm going to have to do this 4 times 5 out front here. 4 5s should give me 20. Plus 2 root 30 plus another 2 root 30 plus 6. All right. Now that I have simplified, there's no perfect squares that go into 30, so I can't pull anything out of there, simplify that any further. Now I just need to combine my like terms. So if I look, I see that I have a couple root 30s, and I have a 20 and a 6, which can be added together. So I'm going to add my 20 and my 6 together to get 26. 2 root 30 plus another 2 root 30 gives me 4 times the square root of 30. And that is it. I can't add the 26 and the 4 together because those are talking about different things. 26 is just an integer, and then the 4 is saying you have 4 groups of root 30. So those are different. We can't add them together. There's no perfect squares that go into 30. So I'm done. There's nothing else I can do there. So you can kind of see how adding and subtracting is important to kind of master first, And before we can even do the adding and subtracting, it's kind of important to make sure you've mastered simplifying your radicals. Are there any perfect squares you can pull out? Are there any perfect cubes you can pull out? One thing that I should have mentioned in this lesson that didn't come up is that if I had something like, I don't even know if you'll get examples like this, 2 times the square root of 30, maybe times 4 times the cube root of, I don't know, 7. When you end up with these sorts of things, what you can do, I'm just kind of guessing that this is going to happen. I don't even know if it's going to happen in the questions or not. You can multiply the 2 and the 4 together and you get 8. And then just leave it as root 30 times the cube root of 7. You can't multiply square roots and cube roots together quite yet. So that's kind of something that I don't know will happen, but I'm just kind of thinking if it does. Taylor's asking a good question here. How do we know when to use FOIL? And can I use it in every question? Taylor, when we use FOIL, we're going to have questions that kind of look like sort of 2 things. So if I had like x plus 2 and, I don't know, 3x plus 7. These are called binomials. So I have polynomials with 2 terms. Anytime I have 2 terms inside the brackets and I'm multiplying 2 sets with 2 terms together, then I'm going to FOIL. And I can go first, outside, inside, and last. That's how I learned it. On the other hand, if you had a question like this, 2x, let's use radicals, I guess we're using radicals here. 2 root 3 times 3 plus 7 root 5. FOIL doesn't work for a question like this because I don't have anything in front here, so I'm just going to distribute or feed my chickens and multiply the 2 root 3 by the 3 and then the 2 root 3 by the 7 root 5. So when we have binomials, 2 binomials, like the first thing I wrote here, these guys, then we can use FOIL. When we have just one thing and then 2 things, then that is called using the distributive principle, and we need to multiply by both of those and feed our chickens. Like D wouldn't work up above here. Let's go back to D and have a look. Yeah, so exactly, letter D, example D, that isn't a binomial. There's only 1 term each. So when we have 2 terms and 2 terms, we FOIL. We have 1 term and 2 terms, we distribute. And then if we just have 2 brackets with only 1 term and 1 term, we just multiply those together. Hopefully that's a little bit clear. I'm just going to peek in at the learning guide. If anybody has any questions about anything I did in the lesson, you can fire away. Try to give myself more time. It looks like I succeeded in giving myself too much time, which is fine. Right as entire radical, so you guys have done that. Number 8, I told you not to worry about. We did 9 and 10. So this is what we're going to be looking at today. The first one here, like terms, is just adding things that are the same. That's pretty self-explanatory, I feel. Adding and subtracting radicals, this is just combining things that are the same. So let's maybe pick a different one. Like this guy here, maybe not that guy. Here, we have 5 root 3's and then we take away 1, so we're going to end up with 4 root 3. I'm going to put a little star next to F, and I'm going to write a little note here. Simplify first. So it's important that we simplify these things before we combine them. And then I think everything after F, it'll become important that you simplify first. And what do I mean by that? Like H here, I have the square root of 50, which can be written as the square root of 25 times 2, which is going to be 5 times root 2. So make sure you're simplifying these. Same with 18, you're going to get 9 and 2. So that's where you're going to run into problems there. Adding, subtracting. Number 2, same process except with cube roots. So don't get freaked out by the cube roots. It's the exact same thing. It's just your roots are going to change. So instead of doing 4 and 9 and 16, you're dealing with 8. It's 2 cubed is 8. And then 3 cubed is 27. 4 cubed is going to be 64. 125 is 5 cubed, and then 216. So these are your perfect cubes. You might want to have those handy for doing these guys. Simplify first. Multiplying and dividing radicals. Simplify each of the following. So there's all multiplication there. Make sure you distribute these types of questions. And then these guys are our FOIL. For like K. That's the first FOIL. Did I not do any division of radicals? Well, that's not good. Let's do a couple of these. Hopefully you guys have your learning guide out. I'm on page number 10. And maybe I'll do a couple. Maybe that's why I had so much free time, because I didn't do any division questions. Same as multiplication. The rules. And Alex, I see your question there, so I'll get to that. I promise. Square root of 6 and 3. Are there any things? Imagine I just had a question that said 6 over 3. Is there anything common between 6 and 3? What can I pull out? So 3 goes into 6 2 times. So 6 divided by 3 is going to give me, you can think about 3 going into 6 twice, root 2 over the square root of 1. What is the square root of 1? Square root of 1 kind of gets tricky because it kind of gets forgotten about with our perfect squares. 1 times 1 equals 1. That is a perfect square technically. So I can take the square root of 1 and I just end up with 1. So I'd end up with root 2 over 1, and I can just write root 2 over 1 as just root 2. So that's the first one. Maybe I'll do B with you guys as well. So I'll write this as root 2 over root 1, because I can pull a 3 out of both of those. Root 2 can't be simplified any further, but the square root of 1 is 1, and I just leave it as root 2. 14 and 2. What's common between 14 and 2? Well, I can pull a 2 out of the bottom and end up with 1, and 14 divided by 2 is 7. So I get root 7 over root 1. Same process as before. Root 7 over square root of 1 is 1, and I end up with root 7. And let's look at E. I'll leave a couple of them for you guys to do as practice. E. There are some numbers in front of our radical sign. So when we're dealing with questions like E, I need to deal with the numbers out front separately from the numbers underneath. So I'm going to deal with the radicals separately from the numbers out in front. So I need to think, are there any common terms between 5 and 10? And yes, I know I'm going to divide 5 by 5 and get 1. 10 divided by 5 is going to give me 2. And then common terms between the 15 and the 3. So I know 3 goes into 3 one time. 3 goes into 15 3 times. So I'm going to rewrite this. I don't have to write it as 1 times the square root of 3, but I'm just going to put it in there just for simplification purposes. That's going to be all divided by, and 2 times the square root of 1. So if I just get rid of my 1's, I end up with root 3 over 2. So there's 3 there for you guys to do as practice. I really apologize for not putting any of these in the examples. I guess I just simply forgot about them. Oops. Maybe look at a couple of these ones. Simplify each of the following, leave in simplest radical form. Right here where it says rationalize all denominators. This means get rid of radicals in the bottom. We can never leave an answer with a square root sign in the denominator. Just one of these math sort of things that we do. So let's pick one. Maybe we'll pick C. I'll do C for us. So we have 6 times the square root of 10 divided by square root of 3. All right. Now, rationalize the denominator means no radicals in bottom of fraction. Gotta get rid of the radicals in the bottom. How can I do that? It's kind of like when we're dealing with simplifying fractions and those sorts of things. I need to get rid of the radical sign in the bottom. And the easiest way to do that is multiply by whatever is there. And if you think about this, if I had something like root 3 times root 3, it's going to give me root 9, and the square root of 9 is just 3. So I know if I multiply the bottom by whatever is there, I'm going to end up getting rid of the radical. Abby's pointing something out here. The dividing radicals question we did is actually square root 5 over 2, not square root 3 over 2. What did I do then? Square root 5 over 2, not square root, 3 goes into 15 5 times. Thanks, guys. That was a silly one. Thanks for catching that. Thank you for pointing out my mistake, because everyone would have gone home with that and been like, I don't understand where this is coming from. Back to the question, letter C, rationalizing the denominator. When I do multiplication with fractions, if I do something to the bottom, I have to do the same thing at the top. And why can I do it this way? Well, what is root 3 divided by root 3? Or what is 7 over 7? Or what is 152 over 152? These things all just equal 1. So I'm just multiplying by 1. I'm not changing anything. It's just really multiplying by 1. If I'm multiplying by root 3 over root 3, I'm multiplying by 1. So what I'm going to do is I'm going to do my multiplication. 6 root 10 times root 3 is 6 root 30. And on the bottom I get root 3 times root 3 is the square root of 9. So 6 root 30, and then the square root of 9 is 3. Once I get the 3, I know that I need to simplify these, and 6 divided by 3 is going to give me 2 times the square root of 30. And this is all just over 1, but I'm not even going to write the 1 in because I don't need to. So let's do one more of those because they can get a bit tricky. Maybe let's do G. I'm going to do G over here on the left side. So root 7 minus 3 over root 3. Same root 3 on the bottom, just a coincidence. So what I'm going to do is I'm going to multiply both the top and bottom by root 3. There's nothing I can simplify here. Root 7 minus 3, I can't combine those. The root 3 on the bottom, I can't simplify anything there because I'm not going to get any whole numbers. So I'm going to multiply both the top and the bottom by root 3. Now, if you think about it on the top, I have to multiply the root 3 by the first number, and I have to multiply it by the second number. On the bottom, there's only one term there, so I'm just going to write it down as root 3 and 3. So root 3 times root 7, 3 and 7 gives me 21, so I have root 21. And I have minus 3 root 3 now, multiplying by both those. And then on the bottom, I have root 3 times root 3, which is just going to give me root 9. Root 21 minus 3 root 3. And then I know I have a 3 on the bottom. Any perfect squares that go into 21, what do we think? 21, 7, and 3, nope, nope, and nope. No perfect squares there. I have this 3 on the bottom. And I could write this separately as root 21 over 3 minus 3 root 3 over 3. Because the division means I'm dividing both of my terms on the top by the 3 on the bottom, so I can write it as two separate ones. The only reason I do that is the 3 and the 3 divide out, and I can end up with just the root 3 there, because 3 divided by 3 is going to give me, I could write it as root 3 over 1 or just root 3. I'm going to leave it like that. Now, I kind of realized that you guys might have a few questions about those ones next day. And I'm fine with that because that's about as tricky as these questions get. The idea is to get rid of any radical signs on the bottom. So try the other ones that I didn't go through, see how you do, and let me know next day. We're finding the area and the perimeter. So area is just length times width. If I wrote the question as 4 root 2 times 3 root 2 plus 2 root 3, you're just going to distribute for the area, length times the width, and you should be good there. And Alex's question, which question did you ask, Alex? Last question on page 11. That is page 11, number 6 here. The rectangular prism has the following dimensions. Find a simplified expression for the volume. So we know volume of a cube is length times width times height. We can call this length, we can call this width, and we can call this height. So we're just going to multiply all of these things together. This is a triple woozy doozy. That's not its official name, but that's what I'm going to call it for today. I'm going to have length root 10 minus root 2 times width root 10 plus root 2 times height root 10 minus root 3. Holy cow, that's going to be a lot. I don't have a fancy acronym for multiplying 3 binomials. I guess they're not binomials, they're biradicals maybe. I don't know if they even have a name. Probably do, I just don't know it. Multiplying 3 things with 2 terms multiplied by each other. So what I'm going to tell you is to do it in 2 steps. You actually find something that interesting happens here. You're going to do your FOIL first, outside, inside, and last. And what you should do is just bring this 10 root 3 down. So you're going to end up with this big mess of stuff. A bunch of these terms are going to actually cancel out on the inside, just kind of the way the question's set up, skillfully set up. So you're going to go 10 times root 10, you get square root of 100, which is just 10. The middle 2 terms are going to cancel, and you're going to find that you should end up with, just off the top of my head, I'm thinking you're going to end up with just 6 here. Don't quote me on that, I'm just doing it quickly in my head. So all of that big mess of the first two multiplications is gonna just leave you a 6. I'm thinking 10, 4, yeah. So then you're just gonna distribute the 6 through the brackets. But I want you to figure out that on your own because there's a few steps in the middle that you need to show. So that's my time for today. Do as much of the booklet as you can. I have a feeling you'll have a few questions about number 3 here. You probably have a few questions maybe on the questions like 5 and 6. And then if you have them, I'll have time at the beginning of next day to answer any questions or review anything from the unit. If you can have a look at quiz number 2 from Unit 1 tonight, that would be great. And then, yeah, that's really it for this unit. So maybe attempt the quiz today if you're feeling confident with this stuff. If not, you can do it tomorrow after I go through the answers to this. You should have your review probably, or the learning guide here that I've just been going through. You should have that submitted maybe by the end of tomorrow, tomorrow night, or maybe Wednesday morning at the latest. I'll get you the password for the test emailed out to you, and then you can write the test when you find some time between now and Friday, or I guess Wednesday and Friday. Even Friday, because it's a Pro D, you'll have all day to do it if you can get the review in before that, and I can get it back to you. So that's kind of my hope. That's kind of the timeline. We still have to move on to Unit 3, so you don't want to leave this stuff too long. So I'm going to actually start Unit 3 next day, and that's kind of where we're at. So hopefully you don't have any pressing questions, and I guess I'll see you guys tomorrow. Mrs. Ward will be on with English at in about 5 or 10 minutes. So we'll probably put up 10 minutes and she'll start then. So go grab a snack, a drink, and see you guys tomorrow. Thanks.